Chloe has a van. She is going to use the van to deliver boxes. Each box is a cuboid, 40 centimetres by 30 centimetres by 35 centimetres. The space for boxes in the van has maximum length of 2.4 metres, maximum width of 1.5 metres, maximum height of 1.4 metres. The space for boxes is empty. Chloe wants to put as many boxes as possible into the van. She can put 3 boxes into the van in 1 minute. Assume that the space for boxes is in the shape of a cuboid. Work out how many minutes it should take Chloe to put as many boxes as possible into the van. So what we can see is the measurements for the boxes in centimetres, however the measurements for the van is in metres. So what we can do is we can convert the measurements for the van into centimetres. So 1 metre is equal to 100 centimetres. So this means that 2.4 metres is equal to 240 centimetres. 1.5 metres is equal to 150 centimetres. And then 1.4 metres is equal to 140 centimetres. So in this cuboid, the side which is 40 centimetres is the length, 30 centimetres is the width, and then 35 centimetres is the height. So now what we'll want to do is work out how many boxes we can fit along the length of this van, along the width of the van, and up the height of the van. So to do this, we can divide the length of the box by the length of the van. So 240 divided by 40 gives us 6, and this means that 6 boxes will fit along the length of the van. Next, we can use the same process to work out how many boxes will fit along the width. So the width of the van is 150 centimetres and the width of the boxes are 30 centimetres. And 150 divided by 30 gives us 5 boxes. And finally the height. The height of the van is 140 centimetres and the height of the box is 35 centimetres. And this gives us an answer of 4 boxes. So what this means is 6 boxes will fit along the length of the van, 5 boxes along the width, and then 4 boxes along the height. So in order to work out how many will fill the full van, we'll need to multiply these 3 numbers together. And 6 multiplied by 5 multiplied by 4 gives us 120 boxes. So the final part of this question is to work out how many minutes it would take Chloe to put the boxes into the van. So she can put 3 boxes into the van in 1 minute. However, we have 120 boxes. So to get from 3 to 120, we need to multiply by 40. So if we've increased the amount of boxes we have by 40, then we can increase the amount of time it will have taken by 40 also. So this means it will take 40 minutes to put as many boxes as possible into the van. And this is our final answer. Now this question's worth 4 marks. We'll get our first mark for working out how many boxes will fit along one of the edges. Our second mark for working out the total number of boxes which will fit into the van. Our second mark for working out the total number of boxes which will fit into the van. Our third mark for working out how many minutes it will take to put these boxes into the van. And our fourth mark for the correct answer. The space for the boxes might not be in the shape of a cuboid. Explain how this would affect the time it would take Chloe to put as many boxes as possible into the van. So in part A, we worked out how many boxes would fit into the van, and all of the boxes fit perfectly inside of the van. However, if this van might not be in the shape of a cuboid, then the boxes may no longer fit inside this van perfectly. And what this means is that less boxes will fit into the van, so therefore it would take less time. So in our answer we can write that if the boxes no longer fit along each edge, then less boxes may fit into the van, meaning it would take less time. Now, although we've written in our answer that it would take less time, if we can argue that it may take more time, this would also get us the mark. So we could also write something like, because a different arrangement would be required, it may take more time. And this question's worth 1 mark, and this is for a suitable reason for our answer.